Hello, my name is Fatih Furkan Akeç, and I'm going to do a challenge lab of Amazon AWS Academy Module 3 of AMLF. And in this lab, uh, we're gonna do predicting airplane delays, and the objectives are process and create dataset from downloaded zip files, perform exploratory data analysis, establish a baseline model, perform hyperparameter optimization, use metrics to compare the performance between models. So this lab requires 300 minutes to complete, but I will pause the video in betweens. So the video uh, will be shorter. So let's name the notebook my flights notebook, and for X large modem size 25, select another pipeline, then choose create notebook instance. So it's pending now. Let me pause the video and then I will continue. So let's open Jupyter Lab. Let's open flight delay IP YMB, and from now we follow the instructions in the notebook. So, introduction to business scenario. We work for a travel booking website that wants to improve the customer experience for flights that were delayed. The company wants to create a feature to let customers know if the flight will be delayed because of the weather when they book a flight to or from the busiest airports for domestic travel in the US. We are asked with solving parts of this problem by using ML to identify whether the flight will be delayed because of the weather. We have been given access to the dataset about the on-time performance of domestic flights that were operated by large air carriers. We can use the data to train an ML model to predict if the flight is going to be delayed for the busiest airports. And about this dataset contains scheduled and actual departure and arrival times reported by certified US air carriers that account for at least 1% of domestic scheduled passenger revenues. The data was collected by the US Office of Airline Information, BTS, and the data set contains dates, time, origin, destination, airline, distance, and delay status of flights for flights between 2013 and 2018. Features. For more information about features in dataset, you can see in this link. Then dataset attributions. Step 1, problem formulation and data collection. Start this project by writing a few sentences that summarize the business problem and the business goal that we want to achieve in this scenario. We can write down our ideas in the following sections. Include a business metric that we would like our team to aspire toward. After we define the information, write the ML problem statement. Finally, add a comment or two about type of ML in this uh, activity represents. Project presentation include a summary of details in this project presentation. So my answer is the dataset includes date, time, place of departure, destination, airline, distance, and delay for flights between 2013 and 18. And in this large dataset, it can provide a solution to the problem by helping us to see if there is a cause or effect relationship or correlation relationship to flight time delay of these situations, and formulate the business problem, success metrics, and desired ML output. So the business problem is customer satisfaction affected by sudden flight delays if no early notice or uh, no early advance. And success metrics, notifications of flight delays can be communicated to customers. Desired ML output, find out if the flight will be delayed due to weather conditions. Identify the type of ML problem that we are working with. This is supervised machine learning. And analyze the appropriateness of the data we are working with. The dataset seems suitable for predicting flight delays due to weather conditions. It includes relevant features like date, time, place of departure, destination, airline, distance, and play. For domestic flights from 2013 to 2018. However, data quality, coverage of busiest airports, and potential inclusion of external weather data should be carefully assessed for a model accuracy. So here's the setup. Now that we have decided where we want to focus our attention, we'll set up this lab so that we can start solving problem. And let's run this cell. So matplotlib is building the font cache. This may take a moment. Step 2, data preprocessing and visualization. In this data preprocessing phase, we explore and visualize things to our data to better understand it. First, import the necessary libraries and read the data into pandas data frame. After we import the data, explore the dataset, look for the shape of the dataset, and explore our columns and the types of columns that we will work with. Numerical, categorical, consider performing basic statistic on the features to get a sense of feature means and ranges. Examine your target column closely and determine its distribution. And specific questions to consider: what can you deduce from the basic statistic that you run on these features? What can you deduce from the distributions of the target classes? Is there anything else you can deduce by exploring the data? So start by bringing in this data set from a public AWS Amazon S3 bucket to this notebook environment. So let's run these cells. Extract comma separated values CSV files from the zip files. So we are downloading the zip files. And then we will extract comma separated values CSV files from the zip files that we downloading now. So the code is run. So let's define zip to CSV function, and with try except method we will extract comma separated values from these zip files. Let's run this cell. So the files extracted. Let's run this cell. We see 60. So let's run this cell. We can see the background and record layout. The data content, the compressed file has been extracted from report carrier on time performance 1987 to present, and the database from Transstats data library. The time period is indicated in the name of the compressed file. For example, xxx underscore xxxxx underscore 2001 x1 contains the data of the first month of the year 2001. You can see record layout, year, quarter, month, etc. in here. So let's define a df temp, data frame temp, and we're gonna write code here, and I just write it while I waiting for these files extracted. So print the row and column length in the dataset and print the column names. To view these columns of the data frame, we use dataframe.shape function. To view column names, use dataframe columns function. So df shape, df temp.shape. Let's run this cell. As we can see, we see rows and columns, and in here we're gonna print the first 10 rows of the dataset. We will use head function of pandas, I think, in here, and let's run this cell too. As we can see, the first 10 rows is like that: year, quarter, month, day of week, flight date, reporting, airline. and .id reporting airline, IATA code reporting airline tail number, etc. going like that. Print all the columns in the dataset to view the column names. Use data frame dot columns. That's right. Df temp dot columns. Let's run it. Yeah, we should do it like that, I think. Yeah, we should do it like that. So as we can see, the column names going like that, and unnamed 109 columns. So print all the columns in the dataset that contain the word del. This will help we see how many columns have delay data in them. Okay. To include values that pass certain if statement criteria, we can use Python list comprehension. For example, x for x in if x greater than 2. So let's code in here. So let's run it. Column names that contain del are deep delay minutes, deep del 15, and so go on like that. Question: how many rows and columns does dataset have? How many years are included in dataset? What is the data range for the dataset? Which airlines are included in the dataset? Which origin and destination airports are covered? And hints are in here. Let's write the codes in here. I'm gonna pause the video and then I will continue. So the codes like that. The rows and columns are df temp shape 0 and 1 for rows and columns. For the years, df temp dot year unique, and the months is same, just like that. Just we change df temp year to month, and for the range, min df temp flight date unique to max df temp flight date unique. Airlines covered, df temp reporting underscore airline unique. These are the column names. The origin airports covered are list df underscore temp dot origin unique, and the destination airports df temp dot dest dot unique. So let's run this cell. So yeah, we have a problem here. Let's run it again. So we can see rows and columns, the years in this data sets, the months covered in this data set. The range for data is the airlines covered in this data set, and the origin airports covered are like that. The destination airports covered are, and here are other question: what is the count of all origin and destination airports? So let's code this. So the code should be like that: df temp origin dot value counts, and for the destination df temp destination dot test dot value counts. Let's run this. So we can see origin and destination of the airport's life. In terms of spot, we have more rows, like 346 by 2. So print the top 15 origin and destination airports based on the number of flights in this dataset. So it should be like that. Let's run it. So we can see now we print the top 15 origin and destination airports based on number of flights in dataset. So given all the information about flight trip, can you predict if it would be delayed? The error del 15 column is an indicator variable that takes the value 1 when the delay is more than 15 minutes. Otherwise, it takes the value of 0. We could use this as a target column for classification problem. Now assume that we are traveling from San Francisco to Los Angeles on a work trip. We want to better manage our reservations in Los Angeles. Thus, want to have an idea of whether our flight will be delayed. Given a set of features, how many features from this dataset would we need to know before our flights? Columns such as depth delay, ARR delay, carrier delay, weather delay, nest delay, security delay, late aircraft delay, and due error delay contain information about delay, but this delay could have occurred at origin or the destination. If there were sudden weather delay 10 minutes before landing, this data wouldn't be helpful to managing our Los Angeles reservations. So simplify the problem statement, consider the following columns to predict an arrival delay: year, quarter, month, day of week, flight date, reporting airline, origin state, destination state, CRS depth time, depth delay minutes, departure delay groups, cancelled, diverted, distance group, array delay minutes, error delay 15, airtime. We will also filter the source and destination airports to be top airports and top 5 airlines. This information should help reducing the size of the data across the CSV files that will be combined. So combine all CSV files. So let's run this cell to combine CSV files, and this process will take 5 to 7 minutes, so I'm gonna pause the video. So it finished running. Let's run this cell and load the dataset. So in here we gotta write code, and it should be like that: data.add5. And as we can see, the 5 columns, and how many rows and columns does dataset have, how many years are included in the dataset, what is the date range for the dataset, which airlines are included in the dataset, which origin and destination airports are covered, like the code be written here. It's just same, and I write it as this code running, so let's run it. As we can see, rows and columns, years in this data set, the months covered, and the data range, airlines covered, origin airports and destination airports in here. And define our target column is underscore delay. 1 means that the arrival time delayed more than 15 minutes, and 0 means all the other cases to rename the column from array arrival delay 15 to is underscore delay is the rename method. Hence we can use the rename function in pandas, and for example like that, let's write our code. So the code should be like that: data.rename columns airdel 15 to is underscore delay. Let's run this cell. So yeah, it should be like that. So we look for nulls across columns. We can use isNull function. So let's write the code: data.isNull and some of the axis 0, and let's run the cell. As we can see, so we will remove all null columns. Let's run it and get the hour of the day in 24-hour time format. The ML problem statement: given a set feature, can you predict if a flight is going to be late more than 15 minutes? Because the target variable takes only a value of 0 or 1. We could use a classification algorithm before we start modeling. It's a good practice to look at feature distribution, correlations, and others. This will give you an idea of non-linearity of patterns in the data. Linear models add power, exponential, or interaction features. Try a non-linear model: data imbalance. Choose metrics that won't give biased model performance accuracy versus the area under the curve or how. Use weighted or custom loss functions. Missing data to imputation based on simple statistic: mean, median, mode, numerical variables, frequent class, categorical variables, clustering based imputation, k nearest neighbors or canons to predict column value, drop column, and data exploration, distribution of classes 0 and 1, as we can see here. 1 is when delay is more than 15 minutes and 0 is otherwise, and the frequency is about 78% I think, and 22% in delay. What can you deduce from the bar plots about the ratio of delay versus no delay? We answered that already. Run the following two cells and answer the questions. So we see percentage in here, and this is for months, and this is for tab hour of day. This is for day of week. This is reporting airline. This is origin airline, and this is destination. And we see distance is delay plot in here. These dots for delay, and this is for distance. For example, in the distance 1000, the delay is 0 and 1 in here. So using the data from the previous charts, answer these questions. Which months have the most delay? And as we can see, 6th, 7th and 8th months are most late months. What time of the day has the most delay? As we can see, around 20, 19 and 21 is the most delayed hours. What day of the week most delay? As we can see, slightly the fourth day of the week has most delay. Which airline has the most delay? As we can see, barely WM airline. And which origin and destination airports have most delay? ORD and SFO airlines. Is a flight distance a factor in the delays? If we look at this plot, we can see 0 is not delayed, 1 is delayed. As we can see, in every distance we have not delayed and delayed. So I think flight distance is a not factor in the delays. Features: look at all the columns and what their specific types are, and we can see the columns and the data types in here. For example, int, object or float. Filtering the required columns, data is redundant because you have a year, quarter, month, day of week to describe the date. Use origin and destination code instead of origin state and destination state. Because you are only classifying whether the flight is delayed or not, you don't need total delay minutes, depth delay minutes, and ARR delay minutes. Check deep hour of day as a categorical variable because it doesn't have any quantitative relation with the target. If you need to do a one-hot encoding of this variable, it would result in 23 more columns. Other alternatives to handling categorical variables include hash encoding, regularized mean encoding, and bucketizing the values, among others. In this case, we can only need to split into buckets. To change column type to category, use sType function, pandas data frame sType. So we use in here sType category. To use hot encoding, use getDummies function in pandas for the categorical columns. that we selected, then we can concatenate those generated features to our original dataset by using the concat function in pandas for encoding categorical variables. We can also use dummy encoding by using keyword draw first true. For more information about dummy encoding, we can see in this link. For example, PD get dummies data frame column 1, column 2, draw first true. So we have coding in here. So the code should be like that. And let's run it. So let me check the code. It should be our day of week. Oh, yes, the day of week. It should be like that, as you can see. So let's run it. And we check the length of the dataset and nav columns. So data head and data shape in here. So it's gonna take a while to run this cell, so I'm gonna pause the video. So as we can see, the data head and data shape is like that. We have 5 rows and 94 columns in here, and this much for set of data, I think. And now we are ready to train the model. Before we split the data, rename is delay column to target. We can use rename function, as we can see before. So let's write this code is underscore delay to target, and let's run the cell. End of step 2, save the project file to our local computer. Follow these steps. Okay, let's download. We saved this. So step 3, model training and evaluation. We must include some preliminary steps when we convert the dataset from a data frame to format that a machine learning algorithm can use. For Amazon SageMaker, we must perform these steps: split data into training data, validation data, test data by using sklearn model selection, training, test, split. Convert the dataset to an appropriate file format that Amazon SageMaker training job can use. This can be either a CSV file or record protobuf. For more information, we can click this link and upload the data to our S3 bucket. If you haven't created one before, see create a bucket Use the following cells to complete these steps. Insert and delete cells where needed. And let's run these cells. And we get a answer like sample answer. Baseline classification model. Let's run this cell. Oh, we got a code here. So let me check it first. So I write the code instance count 1, instance type ML and for X large, predictor type, binary classifier, and binary classifier model selection criteria is cross entropy loss. So let's run it. So linear learner accepts training data in protobuf or CSV content types. It also accepts inference records in protobuf, CSV, or GS object notion JSON content types. Training data has features and ground truth labels, but the data in an inference request has only features. And in a production pipeline, AWS recommends converting data to SageMaker protobuf formats and storing it in S3. So to get up and running quickly, AWS provides record underscore set operation for converting and uploading the dataset when it's small enough to fit in local memory. It accepts NumPy arrays like the ones that we already have, so we'll use it for this step. The record set object will track the temporary Amazon S3 location of our data, create train, validation, and test records by using estimator record set function. Then start your training job by using estimator.fit function. So now we'll train our model on dataset that we just upload. Let's write it classifier underscore estimator dot fit and train records underscore records test underscore records close the parentheses, and let's run it. So the training is completed. The model evaluation. In this section we will evaluate our trained model. So test objective loss, binary F beta, precision and recall values are here. Next we set up some functions to load the test data into S3 and perform prediction. So in here we replace lab bucket name by our bucket name. So we're gonna use that name in here, and then let's run this code, and then let's run this cell too. To run predictions, we run these cells. And let's wait while it's complete. So let's execute it. We import confusion matrix and metrics from sklearn library. So to plot confusion matrix, we write plot confusion matrix line, and the predicted class true class and confusion matrix is here. Okay, questions to consider: how does the model our model performance on the test compare to its performance on the training set? What can we do this from this comparison? Are there obvious differences between the outcomes of metrics like accuracy, precision, and recall? If so, why might you be seeing those differences? Given your business situation and goals, which metric or metrics is most important for to consider? Why? Given business standpoint, is the outcome for the metric or metrics that you consider to be the most important sufficient for what you need? If not, what are some things you might change in your next iteration? This will happen in the feature engineering section, which is next. Use following cells to answer these and other questions. Insert and delete cells where needed. So this is the end of section step 3. So let's download again. And step 4, feature engineering. How might the balance of our two main classes impact model performance, delay and no delay? Do you have any features that are correlated at this stage? Could you perform any feature reduction techniques that might have positive impact on model performance? Can you think of adding some more data or data sets? After performing some feature engineering, how does the performance of our model compare to the first iteration? So add more features, holiday and weather, because of the list of holidays from 2014 and 18 is known. You can create an indicator variable is holiday to mark them. Okay, because here is no, we not coding this to here. Let me see it by data rows. Right, dates, holidays, and close the parentheses. Let's run it. So could bad weather because of rain, heavy winds, or snow lead airplane delays? I will now check. Let's check it. From date column, create another column called month. Let's create it. And analyze and handle small and SNW the columns for missing values by using fill NA to check the missing values for all columns. Use isNA function. Print the index of the rows that are missing values of TAG, Tmax, Tmin, and we got a code here. So it should be like that. Let's run it. And we get sample output, and we can replace missing T-average, Tmax, Tmin values by average value for particular station or airport, because the consecutive rows are missing. Replacing them with a previous value would not be possible. So replace with the mean. Use grab by function, and we grab by month and station. So we write month and station. Let's run it and merge the mean data with the weather data and check for missing values again. We can't see. Drop station month average, T average, Tmax average, Tmin average, Tmax, Tmin, S and WD from dataset. Add origin and destination weather conditions to dataset. It's always good practice to check for nulls or NAs after joins. So let's check it again. Convert the categorical data into numerical by using one-hot encoding and check the new columns. So let's write it. Use delay to start, and let's run the cell. And in here, create the training sets and train validates and test sets and splits underscore data and prints train targets value counts. So let's copy this and paste and change these tests and validates and run the cell. As we can see, our split of data, and here new baseline classifier, see if these new features add any predictive power to the model. And we have sample code here. So Let's write it down. SageMaker linear learner role. SageMaker get description role, and then actually let me copy this for time. And let's run it and train model by using 3 datasets that we just created. So I write the codes and let's run this. Okay, the training job completed. So let's run it, I guess. Let me check it. Yeah, it should be like that. So let's run it again. So let's plot a confusion matrix. The true class 1 and 0 as delayed and late, and predicted class not late and delayed. And try the XGBoost model. Let's run this cell. So let's run these cells too. We have a training here, so I'm gonna pause the video. So training job is completed. Now let's run batch transformer for our new model and evaluate the model on test dataset. So get the predict, target and test labels here, and plot confusion matrix for our targets, predicted and test labels. I wrote this while the model is training. Let's run it. As we can see, true class and predicted class in here, and we can try different thresholds. Hyperparameter optimization, and we will wait until the training job is finished. It might take 25-30 minutes. To monitor hyperparameter optimization jobs in AWS management consoles, on the services menu, choose Amazon SageMaker, choose training hyperparameter tuning jobs. You can check the status of each hyperparameter tuning job, its objective metric value and its logs. Check that the job completed successfully. So let's go here, SageMaker, and training hyperparameter tuning jobs. We could see here Yes, this is a hyperparameter training job, and we can check it here. So let me pause the video while this being executed, and then I will continue. So let's complete it, and training takes about an hour to complete, and as you can see, there's 10 training completed and training durations in here, and we entered there by Amazon SageMaker, and in their training and hyperparameter tuning jobs, and we could find it in here. So let's run other cells. It says we check the job if it's completed, and it says it's completed, and now we have a tuning job, and tuning job will have a model that worked the best. We can get the information about that model from tuning job, and use best estimator and train it by using the delta. I written the code here. Let's run it. So the training job completed. Let's run batch output. Now let's run it and get the predicted target and test labels. Plot a confusion matrix for our target, predicted, and test labels. Let me check it. Okay, so I have 2s, so we can plot true class, predicted class, and confusion matrix in here. 0 is for not delayed and 1 is for delayed. So we can try different hyperparameters and hyperparameter ranges, and it can improve the model, but our lapsation time is almost finished. As you can see in here, we have 29 minutes left, so we don't have any time to train hyperparameters again. So conclusion, we have now iterated through training and auditing our model at least a couple of times. It's time to wrap up this project and reflect on what we learned, what types of steps we might take moving forward, assuming that we had more time. But we don't have actually more time. It's almost finished. Use the following cell to answer some of these questions and other relevant questions. Does our model performance meet our business goal? If not, what are some things we would like to do differently if you had more time tuning? We can fine-tune the hyperparameters more because we have still errors. And how much did your model improve as you made changes to our dataset? Features and hyperparameters. What type of techniques did you employ through this project, and which yielded the greatest improvements in our model? So we can check the other plots in here, then make a comment about this. As we can see, we start like that and then become that, then inputs become that, and finally our matrix is like that. What were some of the biggest challenges that we encountered through this project? Actually, it is the training time. It takes so much time to train hyperparameters. Do you have any unanswered questions about aspects of the pipeline that didn't make sense to you? I don't know, maybe about the hyperparameters, and what were the three most important things that you learned about machine learning while working on this project? We should drop the columns we didn't use. We should use columns we use and group them by which we did before, by group them and search them by del, which is delay. It's like that. Thank you for watching and have a nice day. See you later.